Okay, here we have our first maybe counterintuitive result when it comes to derivatives. We have that the derivative of a product is not the product of the derivatives. It's given by this equation, right? So with the other notation that we're used to, right, it's f of x times g of x. The derivative, right, just to put in the f of x, it's just f prime of x, the derivative times g of x, plus the derivative of g of x times f of x. And we're going to prove this, okay? And again, what we're going to work with is we're going to work with this left-hand side, and we're going to use the definition of a derivative. So I have the limit as h goes to 0 of, and in this case I have f of x plus h times g of x plus h minus f of x times g of x all over h. And what we're going to do is going to seem very phony. It's not going to, it doesn't seem, why am I going to do what I'm about to do here? It doesn't seem to make sense until the end. But what we need to do is we need to add in and subtract out this term. So we need to add in, I'll put in a different color what we're going to add in. So we got f of x plus h times g of x plus h, and I'm gonna put minus, so I'll put it in a different color, what I'm adding in and then just subtracting right out. So minus f of x plus h times g of x plus f of x plus h times g of x. And then back to what we already had. Minus f of x times g of x all over h. And we should see that the purple just cancels itself out. So there's no equality is maintained between these two. And once I have this seemingly, not necessary fact, what I can actually do is I can begin to rewrite this as I like. So how am I going to rewrite this? So I could rewrite this by, what do we have here? We're going to have, in this case, I could factor out in f of x plus h, and I'll get limit as h goes to 0 of f of x plus h times g of x plus h minus g of x. When I factor out this f of x plus h and this f of x plus h. Plus, now here I'm going to factor out that g of x. And I'm left with f of x plus h minus f of x. All of this over h. And this is going to allow me now to split the limit even further. So first I'll use the fact that the sum of a limit, or I'll even show you that first of all I could split it so it's over h here and over h here. That's of course can be done by algebra. And then, again, remember, the limit of a sum is the sum of the limits. So I can write it as limit as h goes to 0 of f of x plus h, and then g of x plus h minus g of x over h, plus limit as h goes to 0 of g of x plus g of x times f of x plus h minus f of x over h. And now at this stage we gotta really be careful, because if I rewrite this so you see it as f of x plus h as something else, right? The limit of a product is the product of the limits. So it's just going to be, and I'm going to try and squeeze in a step here so I don't have to keep writing and I won't run out of space. So limit as h goes to 0 of f of x plus h times the limit as h goes to 0 of this limit, right? Because that's just the product of the two. G of x plus h minus g of x over h. And then this here is g prime of x. So this is just g prime x. And this here is just f of x. Because as h goes to 0, this term goes to 0, this part goes to 0, and then this just becomes f of x. Plus, I could run a similar game here, but it's even simpler because g of x isn't dependent upon h at all. So you could think of it as just taking it outside the limit, and you get g of x times what this is. But the limit as h goes to 0 of this is just f prime of x. And now I've shown what it is that I want. It's in a different order, but that's fine. This here is this, and this one here is this. And that is your differentiation rule for the derivative of a product. This is called the product rule. Product rule. You have to know it to differentiate anytime you're dealing with a product of two functions. If you could even check that this rule will work if one of the two functions is a constant, and it'll give you the rule for the constant, that you could just factor out the constant. But if f or g is not a constant, you must use this rule.